Separators in one form or another are the most used vessel in the energy industry. Scrubbers, knockouts, treaters, drip pots, and gun barrels are all forms of separators. Separation happens in many ways and for a variety of reasons. Think about why you separate what you recycle from the trash. It's helping a process that's going to take place later. It boils down to the fact that there are advantages to separating things. The same is true in the energy industry. Resources come to the surface in many forms and combinations. Separation adds value to the resources. Sometimes we separate components for safety reasons. Nature helps us in the separation process. Often, the differences in specific gravity of a resource are all that is needed to facilitate separation, but they need enough time and a steady state to do so. Retention time is a big factor in the separation process. Retention is the amount of time that a fluid stays in the separator. With enough retention, the different specific gravities will settle or separate from the emulsion. You can see in this example, over time the fluids separate as they move from the inlet side to the outlet. Some other outside influences that are needed to achieve separation are mechanical devices such as diverter plates, wave breakers, mist extractors, and weirs. All three sectors of the energy industry incorporate separation in their processes. Initial separation occurs in the upstream sector. As the resources are moved through the midstream sector and the conditions that they are exposed to change, there is a need to further separate the product. Separation is needed in the downstream sector to achieve the final product before it goes to the consumer. This short list shows the most common places you will find chemical products controlling the separation process. Separation takes place when the makeup of a well stream is not meeting the customer's requirements. There are guidelines to help producers decide the extent of separation needed. We will discuss these guidelines in more detail in Level 2 separation. Here are a few pictures of common styles of separators. The customer's needs determine what type of vessel that the equipment manufacturers make. The size, working pressure, separation capabilities, accessibility to the internals, and whether it's horizontal or vertical could all be factors that determine how a separator gets built. Phases will be discussed multiple times in these chapters. Two-phase simply means that we are separating gas from liquids. Three-phase means that we go a step further and separate gas from oil and oil from water. It all goes back to the customer's requirements. Separators can be high or low pressure. Anything under 500 psi is considered low pressure, and anything above 500 psi is considered high pressure. Kimray provides different options for the controls on these vessels for both high pressure and low pressure. There are times that you have to look closely to see the differences between high and low pressure vessels. One confusing factor is that high pressure controls are sometimes needed on low pressure vessels in order to have proper control. High pressure controls can work well on low pressure vessels. However, low pressure controls do not work well on high pressure vessels. We define mechanical controls as any device that uses levers and linkages to operate. Pneumatic controls use some form of gas to operate and control. These gases can be natural gas produced from the well or air supplied by an outside source like a compressor. There are other gases used in our industry for supply, but these are the most common. Here we see the different combinations of Kimray controls used in different applications. If the operating pressure is low enough, mechanical controls are a great choice. Some regulatory agencies tightly control fugitive gas emissions. Mechanical valves don't use gas to operate and therefore don't emit gas under normal operation. Enclosed buildings usually found in colder climates may not allow pneumatic controls to be used for safety reasons. The quantity and quality of gas is important when choosing pneumatic controls. The process may also dictate when pneumatics are required. For example, metering fluids usually requires pneumatic controls to maintain a level of accuracy because they can be opened and closed quickly. Please familiarize yourself with the basic connections of this vessel.